We're going to start this week by predicting the weather. In particular, we're going to use a very simple model based on what the weather is today to predict what the weather is tomorrow, to then predict what the weather will be in the farther future. This turns out to be a very simple example of something called a Markov process. So, let's have a look at a very naive way for predicting the weather. Here's a table. What does this table show? We have the weather today as sunny, cloudy, or rainy, and it can only be sunny or only cloudy or only rainy. And if today is sunny, cloudy, or rainy, there is a certain probability that tomorrow it will be sunny, cloudy, or rainy. For example, if today is sunny, then there is a 40% chance of it being sunny tomorrow, a 40% chance of it being cloudy tomorrow, and a 20% chance of it being rainy tomorrow. And we've written this as fractions as opposed to percentages. Same thing for cloudy and rainy. If today is cloudy, what is the probability that tomorrow is sunny? To answer this, all we do is we go to the column that says that today is cloudy, and to figure out what the probability is that tomorrow it will be sunny, we see in the table that it's 0.3. So that's our answer, 0.3. The chance that it will be cloudy tomorrow if today is cloudy is again 0.3. Chance that it's rainy tomorrow if today is cloudy is 0.4. Okay, so let's look at the table again. If today is sunny, what is the probability that the day after tomorrow is sunny? Well, this takes a little bit more work. The probability that it will be sunny the day after tomorrow and sunny tomorrow is 0.4 times 0.4. Why is that? Today is sunny. The probability that tomorrow it's sunny is 0.4. And then if tomorrow is sunny again, then the chance that the day after that it's sunny is 0.4. Okay, so we have that. The probability that it will be sunny the day after tomorrow and cloudy tomorrow can be computed as follows. It's sunny today. That gives a probability of 0.4 that it is cloudy tomorrow. That is right here. And then if it's cloudy tomorrow, then there's a chance of 0.3 that it will be sunny the next day. Now, what if today it is sunny and we want to know what the chance is that it will be sunny the day after tomorrow and rainy tomorrow? Well, the chance that it's rainy tomorrow is 0.2. And if it's rainy tomorrow, then the chance that it'll be sunny the day after that is 0.1. That justifies this right here. Now notice that tomorrow it's either sunny, cloudy, or rainy. Probability that it's sunny the day after tomorrow can then be summarized by summing all of these probabilities together, and we get 0.3. We can similarly ask the question, if today is sunny, what is the probability that the day after tomorrow is sunny, or cloudy, or rainy? We've answered the question of what the probability is that it's sunny the day after tomorrow. We can take this one step further and ask the question, if today is sunny, what is the probability that a week from today it is sunny, cloudy, or rainy? Obviously, this would start getting a little bit more involved. We're going to show you how to build up to that answer. To do so, we're going to introduce some notation. We're going to let chi sub s superscript k be the probability that it will be sunny k days from now. Same thing for chi sub c. It's the probability that it will be cloudy k days from now, and chi sub r, which is the probability that it will be rainy k days from now. So notice the superscripts. The superscripts now tell us how many days from now we're talking about. If we go again to this table, then we notice that if this table tells us how to transition from today to tomorrow for any day, then it's the case that if we know what the probabilities are that it's sunny, cloudy, or rainy on day number k, then to come up with the probability that it's sunny, cloudy, or rainy the next day. It's a matter of looking at the probability that you go from sunny to sunny, given that you're sunny, the probability that you go from cloudy to sunny, given that you know it's cloudy on day k, etc. So you end up with this set of linear equations. So here we repeat the set of linear equations, and what we notice is, since we now know how to do a matrix vector multiply, we notice that we can set this up as a matrix times the vector for day k, telling us what the vector will be for day k plus 1. Okay? So now we have set it up as a matrix vector multiply. And what we notice as a result is that we can simply talk about the vector x for day k and day k plus 1, and how you get from vector xk to xk plus 1 is a matter of doing a matrix vector multiply of the transition matrix P, that's this matrix right here, with the state vector xk. What we notice is that matrix vector multiplication in this case is used to compactly write a set of simultaneous linear equations. How would we represent that today, day 0, is cloudy? Well, the probability that it's sunny on day 0 is 0, because we know today is cloudy. The probability that it is cloudy on day 0 is 1, because we know it is cloudy, etc. So we know that x0 is simply the vector 0, 1, 0. But notice that that's simply our friend, the unit basis vector. So if we then look at the vector of probabilities for tomorrow's weather, x super 1, it is given by our transition matrix P times the vector that represents today's weather, which we just argued was 0, 1, 0 because we said today is cloudy. And we know that if you multiply a matrix times a unit basis vector, you simply pick out the appropriate column of the matrix. So it's no big surprise that you get 0.3, 0.3, 0.4 as the answer. Here we simply repeat that if you take P times a unit basis vector, you get the corresponding column. So, if today's weather is cloudy, we can now determine what the vector of probabilities is for the day after tomorrow, x super 2. It is given by the transition matrix P times the weather on day 1. But we just computed that the weather on day 1 is the vector 0.3, 0.3, 0.4, and therefore we can simply do a matrix vector multiply to come up with our answer, which tells us now what the probabilities are for it being sunny, cloudy, or rainy on day number 2. Okay, so now we can revisit what the weather will be a week from now. Or rather, if today is sunny or cloudy or rainy, which you can tell by looking out the window, we can come up with the vector of probabilities that tell us what the probability is that a week from now it's sunny or cloudy or rainy. So how would we do that? Well, we could either do 7 matrix vector multiplies by hand, or we can use some kind of tool. For example, we could use Python. So let's have a look at that. What we have here is a terminal session. In this terminal session, I'm going to start up Python. Okay, so let's import NumPy. Okay, so let's enter our transition matrix P. P is going to be a matrix. So what are the entries for our matrix? 0.4, 0.3, 0.1, that's the first row, 0.4, 0.3, 0.6, that's our second row, and 0.4, 0.2, 0.4, 0.3, which is our third row. Okay, now we don't need that table anymore, so I'm going to expand this. And if we now do P, then we see the matrix that we just entered. Okay. So how did we say we can represent that today is cloudy? Well, we can say that the first vector, x0, which we tend to show as a matrix with one column, has entries 0, 1, 0. If we display this now, we get this. Now, our probabilities for it being sunny, cloudy, or rainy on day 1 can now be computed by doing P times x0. Let's display that. Our probabilities for day 2 are P times x1. That's the day after tomorrow. The day after that is x3. And if we want to look at a week from now, what we want is x7. So we can do x4 is equal to P times x3. x5 is equal to P times x4. x6 is equal to P times x5. And x7 is equal to P times x6. And if we then display x7, then we get the vector of probabilities a week from now. What's very interesting is that from 6 days from now to 7 days from now, these probabilities aren't changing very much. So what's going on there? What's happening is that we're starting to converge to the steady state, which tells us what in general the probabilities are of it being sunny, cloudy, or rainy. Okay, what we have just discussed is a very simple example of a Markov process. Markov processes actually come up in computer science and statistics all the time. What I would like for you to do is to go and look up what a Markov process is and see if you can find some examples, for example, on Wikipedia.